Welcome, dear listener, to a quiet journey through time and scale. Tonight, we are going to follow a path that begins with a single, invisible molecule and ends deep within the heart of a massive, ancient river of ice. It is a story of transformation, of incredible patience, and of the hidden geometry that governs the coldest places on our Earth. We will see how something as small as a speck of dust can grow into a masterpiece of symmetry, and how those masterpieces, when gathered in their trillions, can reshape the very face of our planet. Before we begin our ascent into the clouds, I invite you to settle deeply into your pillows and find your most comfortable, restful position. If you find peace in these quiet explorations of our natural world, please consider gently subscribing and liking this video. It is a small, wonderful way to support this channel and ensure we can continue to create these restful spaces for you to learn and drift off. But for now, simply let your eyes grow heavy. The world outside is moving at its own pace, but here we are moving at the pace of the ice. Take a slow, deep breath in and let it out. Imagine your breathing is beginning to match the rhythm of falling snow, slow, steady, and completely effortless. With every exhale, feel the tension leaving your body. Your feet feel heavy and warm. Your hands are still, your shoulders drop away from your ears, sinking into the softness of your bed. You are perfectly supported. You are safe. You are ready to drift. Let us leave the room behind now. Imagine your mind drifting upward, as light as a whisper. We are rising through the dark, velvety layers of the night sky, moving far above the quiet streets and the sleeping forests. We travel higher and higher through the crisp, thinning air until we reach the silent reaches of the upper atmosphere. Up here, miles above the ground, the air is a deep, bruised purple, fading into the black of space. It is a place of profound stillness and biting cold. Even though it looks empty, this high-altitude world is teeming with hidden activity. It is filled with water vapor, countless trillions of individual water molecules floating in the dark like invisible ghosts. They are moving, tumbling, and vibrating, each one a tiny part of a much larger story. In this freezing, silent theater, the stage is being set for a transformation. The conditions are just right. The air is heavy with moisture, and the temperature has dropped to a point where the invisible is about to become visible. We are standing at the very threshold of a crystal's life, watching as the chaotic dance of molecules begins to find its rhythm. As we drift here, in the thin, cold air of the high clouds, something remarkable is happening. The water vapor, those invisible, ghostly molecules we felt earlier, is beginning to lose its warmth. It is cooling, degree by degree, as it surrenders its energy to the vastness of the night. But even as it cools far below the freezing point, a strange thing occurs. It remains a gas. It lingers in a state of restless, quiet potential. In the world of science, we call this state supersaturation. It is a beautiful, heavy word. Imagine the air as a quiet, invisible vessel that has become overfilled. It is holding more moisture than the laws of physics usually allow at such low temperatures, like a sponge so heavy with water that it seems to defy gravity, or a secret that has become too large to keep. Every cubic inch of this cold, dark sky is packed with these water molecules, crowded together, vibrating with a pent-up energy. They are searching for a place to rest, a surface to cling to, a signal that tells them it is time to change. Close your eyes and try to visualize this invisible dance. These trillions of H2O molecules are bumping into one another in the dark, spinning and tumbling through the void. They are attracted to one another, but they are moving just a bit too fast, and the air is just a bit too empty for them to catch hold. They are like dancers on a polished floor, reaching out for a hand to grasp, but always sliding past. There is a soft, invisible tension in the atmosphere, a feeling of something being held back, a transformation that is overdue. The air is cold enough to freeze, yet it remains clear. This is the mystery of the supercooled cloud without a catalyst. These molecules would simply continue their frantic, freezing journey as a gas, never becoming the beautiful solid structures we know as snow. They are suspended on the very edge of a transformation, caught in the threshold between what they are and what they are meant to become. Feel that stillness for a moment. The air is heavy with expectation. The molecules are slowing down now, their movements becoming less chaotic and more rhythmic, as if they are listening for a distant, silent note. They are waiting for the first solid spark, the tiny microscopic anchor that will allow the invisible to finally take a shape we can see. This waiting is not a struggle. It is a patient, natural pause in the rhythm of the universe. And somewhere, drifting through this saturated darkness, that anchor is approaching, moving through the deep purple sky toward a destiny it does not yet know. We are standing at the very brink of the first solid spark of life for a snowflake. In the vast, dark theater of the upper atmosphere, a transformation is about to begin. For all the moisture and cold we have gathered, something essential is still missing. You see, pure water vapor is a shy traveler. It finds it difficult to turn from a gas into a solid on its own. It needs a guide, a tiny piece of the physical world to show it the way. Scientists call this catalyst a nucleator, but we can think of it as a seed. Imagine a microscopic shake of dust, so light that it weighs almost nothing at all. This tiny grain might have begun its journey thousands of miles away, perhaps lifted by a warm gust of wind from a sun-baked desert, or carried upward from the salt spray of a crashing ocean wave. It might even be a tiny fragment of volcanic ash, or a single golden grain of pollen from a flower that bloomed in a valley far below. This little piece of the earth is now floating high in the freezing air, a silent, lonely wanderer in a sea of invisible vapor. As this tiny seed drifts into a pocket of supersaturated air, the process of nucleation begins. The first few water molecules, which have been dancing so restlessly in the dark, finally find what they have been looking for. They feel the presence of this solid surface, and they are drawn to it. One by one, they begin to slow down. They lose their frantic, vibrating energy and settle onto the surface of the dust grain, clinging to it like a tired traveler, finally finding a place to rest. This is the very first moment of the snowflake's life, the birth of a crystal. It is a quiet, microscopic homecoming. As the first few molecules latch on, they don't simply pile up in a chaotic heap. Even at this infinitesimal scale, there is a hidden rhythm that dictates where each molecule must go. they begin to arrange themselves with incredible precision, laying down the first bricks of a foundation that will eventually support a complex and beautiful structure. This tiny, invisible cluster of water and dust is now the heart of something new. It is no longer just vapor, and it is no longer just a speck of earth. It has become an embryo of ice, a living blueprint for the winter beauty to come. Feel the stillness of this moment as the first layer of ice wraps itself around the grain of dust, cradling it in a cold, clear embrace. The foundation is set. The spark has been lit. Now, the invisible forces of nature are ready to build upon this tiny anchor, using a geometry that is as old as the universe itself. These molecules are beginning to align, preparing to snap into a pattern that will define everything that follows. As these first few water molecules find their place on the tiny seed of dust, they begin to reveal a secret hidden within their very nature. To understand why a snowflake looks the way it does, we have to look even closer, down to the level of the atoms themselves. Each water molecule is a tiny three-part wonder, one oxygen atom and two hydrogen atoms, held together in a shape that looks a bit like a silent microscopic V, but there is something very special about this shape. Water is what we call a polar molecule. This means it isn't perfectly balanced in its electrical charge. One side of the molecule, the side with the hydrogen atoms, carries a gentle positive charge, while the other side, where the oxygen sits, carries a gentle negative charge. Because of this, every single water molecule acts like a tiny, invisible magnet. In the liquid world of a glass of water, these molecules are tumbling over one another, constantly moving and shifting, their magnetic pulls sliding past each other in a fluid, chaotic dance. But here, high in the cold, quiet atmosphere, as they slow down and turn into ice, they can no longer slide. They begin to snap into place. And because they are like magnets, they cannot just join together in any random way. They must align themselves so that their positive and negative ends find a perfect, harmonious match. Think of it as a grand, silent ballroom dance where every dancer must hold hands in a very specific way to keep the rhythm. Because of the unique angle at which the hydrogen atoms are attached to the oxygen, these molecules find that the most stable, comfortable way to hold hands is to form a ring. But not just any ring. To balance their charges and fit together perfectly, they naturally form a ring made of exactly 6 molecules. This is the birth of the hexagon, the 6-sided shape that governs the entire world of snow. This hexagonal lattice is the fundamental geometry of ice. It is a shape of perfect efficiency and balance. When you see a snowflake with 6 beautiful arms, you are seeing the microscopic handshake of these water molecules magnified millions of times. The number 6 is not an accident. It is a physical necessity, a requirement of the universe's own laws of attraction. As more water molecules drift in from the surrounding vapor, they see this first 6-sided ring, and they are drawn to it. They don't just pile on top. They follow the pattern that has already been set. They click into the edges, extending the lattice outward in every direction. Like a tiler laying down a floor of perfectly matching hexagonal stones, the molecules build a crystalline carpet that is strong, orderly, and incredibly light. Imagine this lattice expanding, a silent, growing grid of invisible magnets, all locked in a cold embrace. It is becoming a solid structure, a tiny scaffolding of ice that is beginning to take up real space in the air. This lattice is the skeleton of the snowflake. It is the invisible map that tells every future molecule exactly where it belongs. And as this map grows, it begins to form distinct surfaces, flat, smooth planes that will soon define the outward appearance of the crystal. We are moving from the world of individual molecules into the world of form, where the first hints of a visible crystal are about to emerge from the freezing mist. The foundation is no longer just a speck of dust. It is a growing, shimmering platform of ice, preparing to take its first recognizable shape. As this tiny scaffolding of ice continues to expand, it begins to take on a more defined three-dimensional structure. Even at this microscopic scale, the snowflake is developing a specific geography. It has a top, a bottom, and 6 distinct sides. Scientists refer to the flat top and bottom surfaces as the basal planes. These are the broad, smooth faces of the crystal. The 6 vertical sides that connect them are known as the prism facets. Together, they form a shape that looks very much like a tiny translucent drum or a hexagonal coin, so small it would be invisible to the naked eye. Now, imagine the air around this little crystal. It is filled with water vapor, countless individual molecules drifting through the cold. These molecules are constantly bumping into the growing crystal, looking for a place to settle down and join the structure. But they are selective. In the quiet, orderly world of crystal growth, some spots are much more attractive than others. The molecules find it much easier to attach themselves to the corners of the hexagon rather than the flat surfaces. If you imagine the crystal as a building, the corners are like open doorways where it is easy to step inside and find a seat. A molecule landing on a flat face has fewer neighbors to hold on to, making it more likely to vibrate and bounce back off into the air. But at a corner, there are more points of connection, more hands to hold. This means the crystal naturally begins to grow faster at its 6 corners than it does on its flat faces. As these corners reach outward, the crystal expands horizontally, becoming wider and wider while remaining very thin. This is how the snowflake achieves its characteristic flat shape. It isn't growing into a block or a cube, it is becoming a delicate, 6-sided plate. It is a moment of quiet, geometric perfection. At this stage, the snowflake is a simple, elegant hexagon, clear as glass and perfectly symmetrical. If you were to look at it now, you might see a tinny shimmering speck reflecting the dim light of the high atmosphere. It is stable, balanced, and remarkably strong for its size. But this simple plate is only the beginning of the journey. The snowflake is not a static object, it is a traveler. It is beginning a long, slow descent through the clouds, and as it moves, it will encounter different pockets of air. The atmosphere is a tapestry of varying moisture and shifting warmth. As our little hexagonal plate drifts downward, the conditions around it will fluctuate. These subtle changes in the environment act like a set of instructions, telling the crystal how to grow next. The simple flat plate is the foundation, a clean canvas of ice. Soon, the edges of this plate will begin to change, responding to the invisible forces of the sky, preparing to move from a simple geometric shape into the complex, branching masterpiece we recognize as a fallen snowflake. The quiet growth continues one molecule at a time as the crystal prepares for the next stage of its transformation. As our tiny hexagonal plate begins its long, drifting descent, it enters a world of invisible boundaries. You might imagine the atmosphere not as a single mass of air, but as a series of quiet, vast rooms stacked one on top of the other, each with its own unique climate and its own set of rules. In the science of snow, the specific shape a crystal takes is known as its habit. And this habit is dictated almost entirely by the temperature of the air it passes through. It is a silent, rhythmic dialogue between the ice and the cold. It is a delicate balance, one that reveals just how sensitive the natural world can be. If the air through which the crystal falls is just a few degrees below freezing, around 28 degrees Fahrenheit, the snowflake prefers to grow as a flat, thin plate. In this temperature range, the water molecules find it easiest to attach to the sides, spreading out wide and elegant while remaining very slim. But as the flake continues its journey, it might drift downward into a pocket of air that is only slightly colder, perhaps reaching 23 degrees Fahrenheit. In this subtle shift of just 5 degrees, the entire architecture of the crystal changes. Instead of spreading out into a wide plate, the water molecules begin to stack themselves differently. They begin to favor vertical growth, stretching into long, slender needles or hollow pencil-like columns. It is as if the crystal has received a new set of blueprints mid-flight, a sudden change in instructions from a silent conductor. This sensitivity is one of the most beautiful aspects of atmospheric science. A difference of just a few degrees, a change so small we might barely feel it on our own skin, is enough to completely rewrite the geometry of the ice. As you lie there, perhaps you can visualize this tiny traveler dancing through these invisible layers. It is not falling in a straight, heavy line. It is caught in the gentle updrafts and soft, swirling eddies of the clouds. It is a slow, weightless tumble through a vertical gallery of possibilities. One moment, it is a plate. The next, it is a needle. And if it drifts back into a warmer layer, it may begin to grow plates once again. On the ends of those needles, every flake becomes a physical record of its own journey, a tiny frozen diary of the temperatures it encountered on its way to the earth. The crystal is constantly tasting the air, responding to the invisible cues of the environment. It is a process of constant adaptation, requiring no effort, only a quiet surrender to the laws of physics. Now, as our flake continues to descend, it begins to enter a region where the air is not just cold, but increasingly heavy with moisture. The simple, solid edges of the hexagon are about to encounter a new force. The quiet, steady growth of the plate is reaching a tipping point, preparing for a transition from simple geometry into the complex, branching artistry that defines the winter landscape. The stage is set for the crystal to reach out further into the mist, seeking the water that will allow it to truly expand. The snowflake drifts into these wetter pockets of the atmosphere. It enters a state of high humidity. Here, The air is saturated, thick with invisible water vapor just waiting for a surface to call home. This abundance of moisture triggers a beautiful transformation known as dendritic growth. The word dendritic comes from the Greek word for tree-like, and that is exactly what begins to happen. The 6 corners of our tiny hexagonal plate start to reach out. Because the corners are the furthest points from the center, they encounter the surrounding water vapor first. It is a simple matter of proximity. The molecules in the air are more likely to bump into these sharp points than the flat, recessed sides of the crystal. Imagine those 6 corners as tiny, eager fingers stretching out into the mist. Once a corner grows even a tiny bit further than the rest, it becomes even more likely to catch more water. It is a gentle, natural feedback loop. From each of the 6 corners, a long, slender arm begins to sprout, pushing outward into the cold, damp air. These are the stellar arms, the points of a frozen star. But it does not stop with 6 simple lines. As these main arms grow, they too develop their own corners and edges. Small side branches begin to bud off the main stems, creating a complex, fern-like structure. This is the birth of the stellar dendrite, the most iconic and recognizable of all snow crystals. It is the archetype of winter, a miniature masterpiece of branching lace that looks as though it were fashioned by a master jeweler. As you watch this in your mind's eye, see how the crystal expands, filling the empty space around it with delicate, icy fractals. The simple hexagon has blossomed into a star. What is most striking about this process is the uncanny harmony of it all. As the crystal tumbles through the sky, all 6 arms begin to grow at nearly the exact same rate. If one arm sprouts a tiny side branch at a specific angle, the other 5 arms usually do the same, almost in perfect unison. This isn't because the arms are communicating with each other across the body of the flake, but because they are all experiencing the same environment at the same time. They are so small that the conditions at one tip are virtually identical to the conditions at the tip on the opposite side. They are like 6 dancers performing the same choreography in different parts of the same room, guided by the invisible music of the atmosphere. The result is a stunning 6-fold symmetry that feels almost intentional, as if a tiny architect were overseeing every microscopic addition. This symmetry is what gives the snowflake its soul, a sense of order born from the chaos of a winter storm. It is a quiet, rhythmic unfolding, a slow-motion explosion of geometry that happens millions of times over in every cloud. As the flake grows larger and more complex, it becomes heavier, more susceptible to the pull of the earth below. Yet its journey is far from over. Each branch and sub-branch is a testament to the stillness and the moisture of the air, a perfect balance of physics and art. Feel the weightlessness of that crystal as it continues to expand, its 6 arms reaching out like a soft, frozen embrace, capturing the very essence of the quiet sky. The beauty of this 6-fold symmetry lies in a simple, elegant truth. Each of the 6 arms is experiencing the exact same life story at the exact same time. As the snowflake drifts through the clouds, it is so incredibly small that the air surrounding it is virtually identical from one side of the crystal to the other. To us, a few millimeters might seem like nothing, but in the world of molecular growth, it is the entire universe. Because every arm is bathed in the same level of humidity and the same precise temperature, they all receive the same instructions for how to grow. If the air becomes slightly more moist, every arm captures those extra water molecules simultaneously. If the temperature shifts just a fraction of a degree, every arm responds by branching out at that very same moment. It is a synchronized dance across a microscopic stage. There is no central brain directing the growth, no hidden blueprint telling the left arm to match the right. Instead, the symmetry is a reflection of the environment itself. The snowflake is a physical record of the conditions it has encountered because all 6 arms are traveling together, locked in that hexagonal lattice. They share every encounter with the atmosphere. They are like 6 mirrors facing inward while catching the same light. This near-perfect symmetry creates a sense of profound balance, a quiet order that emerges naturally from the cold, damp air. It is a testament to the consistency of the physical laws that govern our world, even in the smallest, most fleeting of forms. As you think of this, let your mind drift into the stillness of the upper atmosphere where this crystal is suspended. Imagine the silence of that high-altitude world, far above the noise and bustle of the earth below. There is a deep restorative quiet here. The air is thin and cold, and the only movement is the slow rhythmic tumble of ice through the clouds. Take a slow, deep breath, matching the unhurried pace of the falling snow. Feel the coolness of the air as you inhale, and the softness of your pillow as you exhale. In this space, there is no rush, no urgency. There is only the steady, patient growth of the ice unfolding one molecule at a time. It is fascinating to realize that while each arm of a single snowflake is a near-perfect replica of its neighbors, the snowflake as a whole remains a singular entity. This brings us to one of the most famous mysteries of the winter season: the idea that no 2 snowflakes are ever exactly alike. If the atmosphere provides such consistent instructions to the 6 arms of one flake, you might wonder why it doesn't provide those same instructions to every other flake in the storm. The answer lies not in the molecules themselves, but in the journey the crystal takes. As our symmetrical star begins to feel the weight of its own beauty, it starts a long, winding descent toward the ground. And it is in this journey, through the shifting layers of the sky, that its true individuality begins to emerge. The journey that a single snowflake takes from the high atmosphere to the cold ground is a solitary one. While billions of its kin may be falling at the same time, no 2 crystals will ever follow the exact same path through the air. The sky is not a uniform void. It is a complex, swirling tapestry of microclimates. There are many pockets where the air is slightly more humid, and others where it is a fraction of a degree cooler. As our 6-armed star drifts through these invisible landscapes, its growth is dictated entirely by these subtle, shifting shifts in its surroundings. In science, we call this path dependency. It means that the final form of the crystal depends not just on the conditions it is in right now, but on the specific chronological sequence of every condition it has experienced since the moment of its birth. If a snowflake encounters a burst of moisture early in its life, it might sprout long, delicate branches. If it then passes through a drier layer of air, those branches might stop growing outward and instead begin to thicken into flat plates. Another flake, starting its journey just a few inches away, might encounter those same layers in a slightly different order, or perhaps it misses the moist pocket entirely. This unique sequence of events is written into the very geometry of the ice, creating a physical autobiography of the flakes, time, and the clouds. When you consider the staggering complexity of the atmosphere, the mathematical improbability of two flakes being truly identical becomes clear. A typical snowflake is composed of roughly 1 quintillion water molecules. That is, a 1 followed by 18 zeros. The number of ways those molecules can be arranged as the flake tumbles, rotates, and turns through the chaotic layers of the clouds is essentially infinite. It is a number so large that it defies easy comprehension, far exceeding the number of stars in the observable universe. For two snowflakes to be exactly the same, they would have to follow the same microscopic path, molecule for molecule, through an ever-changing sky. They would have to share the exact same life story second by second, encounter by encounter. As you settle deeper into your blankets, imagine these billions of unique stories quietly unfolding in the dark winter sky above. Each flake is a masterpiece of chance and physics, a fleeting moment of perfect individuality that will never be repeated in all of history. There is a profound peace in this realization that nature creates such intricate, unrepeatable beauty in total silence, without any need for an audience. As the crystal continues to gather mass, it eventually becomes too heavy to be held aloft by the gentle updrafts of the high clouds. The invisible hand of gravity begins to pull more firmly on its delicate structure. The flake tilts, caught in a soft downward current, and begins its long, slow, and heavy descent toward the earth below. It leaves the turbulent nursery of the high clouds and enters the quieter, stiller air of the lower atmosphere, beginning the final stage of its journey toward the waiting world. As the snowflake begins its long descent, it does not plummet toward the earth. Instead, it drifts with a leisure that seems almost intentional, as if it is savoring every inch of the cool, quiet air. While a raindrop might race toward the ground at nearly 20 miles per hour, a snowflake is far more patient. On average, these delicate crystals travel at a speed of only 1 to 4 miles per hour. To put that into perspective, it is roughly the pace of a very slow, contemplative walk through a quiet garden. If you were standing in a field as the snow began to fall, you could easily outpace a single flake simply by strolling along beside it. This unhurried pace is the result of a beautiful balance between two opposing forces. On one hand, gravity is pulling the crystal downward, seeking to bring it home to the soil. On the other hand, the air itself provides a gentle resistance, a force known as drag. Because a snowflake is so light and has such an intricate, spread out shape, it catches the air like a tiny frozen parachute. Every one of those 6 delicate arms acts as a sail, pushing against the molecules of the atmosphere. In the language of science, we call the result of this balance terminal velocity. This is the point where the upward push of the air resistance perfectly matches the downward pull of gravity. For something as dense as a stone, terminal velocity is reached at a very high speed. But for a snowflake, whose body is composed of thin lattices and a great deal of empty space, terminal velocity is reached almost instantly and at a very low threshold. It reaches its cruising speed within a fraction of a second after it begins to fall, and from there it simply floats, cradled by the very air it passes through. Imagine the immense journey this requires. From the high, gray belly of a cloud to the surface of a frozen lake or a quiet rooftop, a snowflake might spend an hour or more in transit. During this time, it is entirely at the mercy of the wind, dancing and tumbling in slow motion. As you breathe in slowly, try to mirror that same sense of weightlessness. Feel the tension leaving your shoulders as if you too are simply drifting through a calm, supportive medium, moving only as fast as the air allows. As the sky fills with these billions of falling crystals, the world below begins to undergo a transformation. What started as a few scattered sparks in the air gradually becomes a collective presence. You can almost feel the atmosphere thickening, growing softer and more muffled as the air becomes crowded with falling ice. The individual identities of the flakes, those unique one in a quintillion geometries, begin to merge into a single, unified phenomenon. They are no longer just lonely wanderers in the sky. They are becoming part of a vast white blanket. This transition from the individual to the collective is one of the most peaceful sights in nature. One flake by itself is nearly invisible, a mere speck of light. But together, they create a heavy, silent curtain that drapes over the trees, the hills, and the valleys. The landscape waits in quiet anticipation, ready to receive this gift from the clouds as the first few flakes finally drift toward their destination. However, as they enter the denser, wetter air closer to the ground, the journey can become more complicated, and the delicate crystal may have to weather one final icy transformation before it can truly rest. As the snowflake continues its slow motion tumble through the lower reaches of the atmosphere, it often enters a region where the air is thick with a peculiar substance, supercooled water droplets. These are tiny beads of liquid water that exist in a state of impossible cold, temperatures well below the freezing point, yet they remain liquid because they lack a solid structure to trigger their transformation into ice. They are like a held breath, waiting for a reason to exhale. When our delicate, six-armed crystal drifts through this mist, it provides that reason. As the snowflake touches these droplets, they freeze instantly upon contact. This process is known to scientists as rhyming. It is a quiet, microscopic drama. Each droplet that latches onto the flake loses its liquid form and becomes a tiny opaque bump of frost on the crystal surface. At first, the rhyming might only lightly dust the edges of the snowflake, like a fine coating of sugar on a pastry. But if the descent is long and the moisture is heavy, the process continues until the original intricate geometry of the flake begins to disappear. The sharp, elegant points of the dendritic arms are softened and buried under layers of frozen rime. Eventually, the snowflake may lose its recognizable star-like shape entirely, transforming into what is known as graupel, or snow pellets. Graupel looks very different from the classic snowflake. It resembles a tiny, soft white bead, almost like a miniature piece of popcorn or a speck of polystyrene. In this state, the flake has traded its ethereal beauty for a certain ruggedness. It is denser now, falling a bit more directly, less prone to the whims of the breeze. There is a subtle tension here, a struggle between the delicate mathematical perfection of the initial crystal and the chaotic, wet environment of the lower clouds. The environment effectively clothes the crystal in a heavy winter coat of frost, protecting the core but obscuring the art beneath. Even as these heavier pellets and rimed flakes begin to dominate the air, they bring with them a profound change in the atmosphere. You might notice during a heavy snowfall how the very air seems to hold its breath. The world becomes strangely, beautifully hushed. This is the hallmark of a true winter's peace. As the flakes and graupel fall in their billions, they don't just fill the space. They change the way energy moves through it. Take a slow, deep breath now, and imagine that same hush settling over your own surroundings. Feel the way the heavy, damp air of a snowstorm seems to press gently against the windows, keeping the noise of the outside world at a distance. The frantic energy of the day is being blunted, just like the sharp points of the snowflake under the rime. Everything is becoming softer, more rounded, and infinitely more quiet. This silence is not an accident of the mind. It is a physical reality of the snow itself. As the flakes finally reach the earth and begin to pile upon one another, they create a structure that is more air than ice. This collective blanket, made of millions of tiny rimed crystals and soft pellets of graupel, acts as a vast natural singe for sound. The journey from the high clouds has brought the flake to its final destination, where it will join its kin to create one of the most effective acoustic insulators found in nature. As the ground turns white, the volume of the world is turned down, layer by layer, until only the sound of your own steady breathing remains. When we look at a fresh drift of snow, it appears as a solid, white mass, a heavy, cold weight upon the earth. But if we were to look closer, peering into the microscopic architecture of that drift, we would find that it is surprisingly hollow. Freshly fallen snow is, in fact, composed of roughly 90% air. It is a paradox of nature. A substance that looks so substantial is actually mostly nothingness. This incredible ratio, 9 parts air to 1 part ice, is the secret behind the snow's soft, fluffy texture and its remarkable ability to change the feeling of the world around you. Because the snowflakes we've followed have such intricate branching arms and irregular rimed surfaces, they cannot pack tightly together when they first land. They don't stack like flat stones or bricks. Instead, they catch on one another at random angles like a pile of tangled branches in a forest. This creates a vast, complex network of tiny, interconnected air pockets. It is within these microscopic gaps that the magic of the winter hush truly resides. This air-trapping structure makes a fresh layer of snow one of the most effective acoustic insulators found in the natural world. Imagine a sound wave, perhaps the distant rumble of a passing train, or the sharp call of a crow traveling through the winter air. In a landscape of bare rock or hard pavement, that sound wave would hit the surface and bounce back, echoing and maintaining its intensity. But when that same sound wave meets a blanket of fresh snow, it finds no hard surface to reflect from. Instead, the sound wave enters those millions of tiny air pockets. It becomes trapped in the labyrinth of ice crystals, bouncing from one delicate arm to another, losing a bit of energy with every tiny collision. By the time the sound might have found its way out, its energy has been entirely absorbed and dissipated as a microscopic, imperceptible amount of heat. This is the physical reason why the world feels so profoundly, almost unnervingly quiet during a snowstorm. It is not just your imagination. It is a literal dampening of the world's volume. The snow acts like the thick, heavy padding of a grand theater, swallowing the sharp edges of the day and leaving behind a heavy, peaceful stillness. Even the sounds of your own movements are transformed. A footstep that would normally click on a sidewalk is muffled into a soft, low-frequency thud, barely a whisper against the white ground. In this environment, the silence becomes a tangible presence, a velvet curtain drawn across the landscape, inviting you to lower your own voice, slow your heart rate, and simply exist within the quiet. But this airy, silent state is fleeting. As the snow settles onto the earth, it begins a slow and inevitable process of change. It is no longer a collection of individual travelers from the clouds. It has become a single collective body. The very weight of the snow itself, though light in small amounts, begins to add up. The flakes at the bottom of the pile feel the gentle, constant pressure of the flakes above them. The 90% air that provided such wonderful insulation begins to be slowly, almost imperceptibly squeezed out. The snow is beginning to settle, to compact, and to find a new kind of strength. As the sun sets or the temperature shifts, the internal world of the snowpack remains active. The individual identities of the flakes are starting to blur, their delicate edges softening as they press against their neighbors. They are preparing for a transformation that occurs without any melting at all, a process of bonding that will turn a soft, fragile powder into a resilient structure capable of enduring for weeks or months. The journey of the individual crystal is ending, and the life of the snowpack is just beginning. The silence of the fresh snow is a sign of its openness, its airy nature. But as the hours pass, a subtle and remarkable change begins to take place within the layers of the snowpack. Even if the air remains well below freezing, the individual crystals do not simply sit beside one another in isolation. Instead, they begin to fuse. This silent, cold bonding is a process scientists call sintering. It is a form of natural welding that happens without a single drop of liquid water, a transformation that turns a pile of loose, fragile flakes into a cohesive and resilient structure. If we could shrink ourselves down to the size of a dust mote and look into the gaps between the snowflakes, we would see a slow-motion dance of molecules. Water molecules are restless by nature. Even in their solid, frozen state, they possess a tiny amount of energy that allows them to vibrate and occasionally break free from the surface of an ice crystal. These molecules drift through the microscopic pockets of air within the snowpack, searching for a new place to land. They are naturally drawn to the points of contact, the places where one snowflake's arm rests against another's. These contact points are known as necks. As more and more molecules migrate toward these necks, they begin to pile up, filling in the sharp angles and building a solid bridge of ice between the two crystals. It is as if the snow is reaching out to hold hands with its neighbors, forming a vast interconnected web. This is why, after a few hours or a day of sitting, a pile of snow that was once light and powdery becomes firm. You might notice this when you try to step through it. The snow that was once like dust now offers a bit of resistance, perhaps cracking into soft blocks or supporting a fraction of your weight before giving way. This structural integrity is what allows the snow to hold its shape. It is what makes it possible to pack a snowball or carve a block for a shelter. The sintering process is constantly working, reinforcing the bridges, making the snow denser and stronger with every passing hour. The sharp, intricate points of the original stellar dendrites, those beautiful six-armed stars, begin to disappear as their molecules move toward the necks. The crystals become more rounded, more communal, losing their individual artistry to contribute to the strength of the whole. In a typical winter, this process might continue for a few days or weeks before a warm spell arrives to melt the snow back into the soil. But in certain parts of our world, the story doesn't end with the spring thaw. In the high, thin air of great mountain ranges or the vast, frozen reaches of the poles, the snow finds a different destiny. Here, the sun's warmth is never quite enough to undo the work of the winter. The snow survives the summer, buried under the next year's arrival, beginning a journey that spans not just seasons, but centuries. The sintering we see in a backyard snowdrift is merely the first chapter in a much longer, much heavier story of transformation, where the passage of time is measured in layers of white. In these secluded parts of the world, the snow becomes a permanent resident of the landscape, while the lowlands turn green and the rivers swell with the spring runoff. The high mountain peaks and the vast polar plateaus remain draped in white. Here, the sun's warmth is a mere suggestion, unable to penetrate the deep chill of the earth and air. This is what we call perennial snow, snow that has weathered the heat of a summer and remains to see the first flakes of the following autumn. It is a quiet, steady presence, a foundation upon which the future will be built. As the new season arrives, fresh snow begins to fall, layer upon layer, stacking up like the pages of a very long book. This is where the true transformation begins. Each new storm adds more weight to the snowpack. At first, it is just a feather-light dusting, but over months and years, the cumulative weight becomes immense. This is known as overburden pressure. The snow at the bottom of the stack is no longer just a collection of delicate crystals. It is now a foundation, bearing the heavy burden of everything that has fallen since. Think for a moment about that sense of weight and pressure. It is not a harsh or crushing force, but a slow, steady settling. As you lie there, you might feel a similar sensation in your own body. Take a deep, slow breath in, and as you exhale, let the weight of your limbs sink just a little deeper into your bed. Feel the gravity pulling you gently downward, grounding you much like the weight of the new snow presses into the old. There is a comfort in this weight, a sense of being held and supported by the surface beneath you. Your shoulders can soften, your legs can grow heavy, and you can let go of the need to hold yourself up. Under this constant gentle pressure, the snow beneath the surface begins to change. The air that once filled 90% of the snowpack is slowly squeezed out. The delicate arms of the snowflakes, already softened by the sintering process we spoke of earlier, are pressed closer and closer together. They begin to lose their individuality entirely, merging into a denser, grainier substance. This is the transition point, the bridge between the ephemeral world of a winter storm and the ancient world of the glacier. Scientists have a specific name for this intermediate state. It is no longer called snow, but it has not yet earned the name of ice. It is called Föhn, derived from a Swiss-German word meaning of last year. Föhn is the record of winters past, a substance that has survived the sun and is now being forged by the weight of time itself. It marks the beginning of a metamorphosis that will eventually turn a fragile flake of snow into a massive, slow-moving river of blue ice. Imagine for a moment the texture of this Föhn. It is no longer the light, airy fluff that drifts through a winter sky dancing on the breeze. Instead, it has become something far more substantial, more grounded. If you were to reach down and hold a handful of it, it would feel like wet, heavy sugar, coarse, grainy, and remarkably cold. The delicate, six-sided symmetry of those original snowflakes has been forgotten by the earth, replaced by rounded grains that nestle tightly against one another. This is the stage where the snow begins to lose that brilliant, reflective whiteness and starts to take on a more translucent, glassy quality, as if it is preparing for a deeper change. The science of this transformation is a quiet study in density and persistence. When that first flake originally landed, it was mostly air. Perhaps 90% of its volume was nothingness, a hollow architecture of frozen water. In that initial state, its density was very low, only about 0.1 grams per cubic centimeter. It was a ghost of a solid, barely there at all. But as the seasons pass and the weight of the overhead snowpack presses down with an unceasing silent force, that air is systematically evicted. The grains are forced together, filling the gaps, closing the corridors where the mountain air once moved freely. Slowly, almost imperceptibly, the density begins to climb. It rises from that initial 0.1 to 0.4, then 0.6, eventually reaching nearly 0.8 grams per cubic centimeter. At this stage, the Föhn is incredibly heavy. It is packed so tightly that it feels almost like solid stone underfoot, yet it still holds on to a final secret. Within this dense, grainy mass, the tiny pockets of air are still connected to one another. Like a network of microscopic caves or a labyrinth of invisible threads, the air can still find a path to the surface, however winding and difficult that path may be. This is the defining characteristic of Föhn. It is a porous solid. It is the essential bridge between two worlds, a substance in waiting. It is the memory of 1,000 storms distilled into a heavy, grainy blanket that covers the high peaks and the polar plains. It represents the patience of the natural world, the way that time and pressure can take something as fleeting as a snowflake and turn it into something that can endure for centuries. As you continue to breathe slowly and deeply, matching the rhythm of your heart to the quiet stillness of the room, imagine this process of settling happening within your own mind. Just as the air is squeezed out of the snow to create something stronger and more enduring, let the busy, light thoughts of your day be squeezed out by the calm, steady weight of your relaxation. There is no room here for the fluttering distractions of the afternoon. Only the heavy, peaceful stillness remains, settling into a firm and comfortable foundation for your rest. The fern will remain in this state for a long time, sometimes years, sometimes even decades, in the driest parts of the world. But the pressure of the world above never lets up. Gravity is a patient force, never sleeping, never relenting, always pulling everything toward the center of the earth. Eventually, the density will climb just a little higher, and the last remaining pathways for the air will be pinched shut, sealing the fate of the crystals. When that happens, the transformation will finally be complete. The grains will no longer be grains. They will fuse into a single, massive body of ancient frozen water. The porous fern will cross the final threshold to become true glacial ice, a substance so dense and pure that it begins to change the very nature of the light that touches it. As the density reaches that critical point of 0.83 grams per cubic centimeter, a quiet and monumental shift occurs. The tiny winding tunnels that once allowed the mountain air to move through the fern are finally irrevocably pinched shut. When those air bubbles are no longer connected to one another or to the surface, the substance officially crosses the threshold into glacial ice. This is the final stage of the snowflake's long journey from the clouds. It has been compressed and transformed, losing its airy lightness to become something ancient, heavy, and incredibly strong. Inside this deep frozen world, a process called recrystallization is taking place. Under the unrelenting pressure of the layers above, the individual ice grains begin to merge and grow. In a single snowflake, the crystals are so small they are barely visible to the naked eye. But here, in the heavy stillness of the glacier, the ice crystals can grow to be the size of a marble, then a golf ball, and in some cases as large as a human fist. These massive crystals are packed together so tightly that there is almost no space left between them. They interlock with one another like a giant frozen puzzle, forming a solid mass that behaves more like a metamorphic rock than it does like the snow you might find on a winter morning. As this transformation occurs, the visual character of the ice undergoes a breathtaking change. When we look at a fresh blanket of snow on the ground, we see a brilliant opaque white. This is because the snow is full of air and millions of tiny crystal surfaces that scatter every bit of light that hits them, reflecting all the colors of the spectrum back to our eyes at once. But as the air is squeezed out and the ice becomes denser and more uniform, that whiteness begins to fade. The ice starts to become translucent. It begins to swallow the light rather than reflecting it. If you were to stand deep within a glacial cave or look into a deep crack in the ice, you would see a color unlike anything else in nature. The ice begins to glow with a deep, heavy, liquid blue. It is the color of the deepest parts of the sea or the sky just after the sun has slipped below the horizon. This isn't a color painted onto the surface. It is a color that seems to radiate from within the ice itself, a frozen light trapped in time. This transition from white to blue is the signal that the ice has reached its full maturity. It is no longer just a collection of fallen flakes. It has become a single, unified body of frozen history. The blue light that escapes from the depths of the glacier is a whisper of the incredible density and purity that has been achieved over hundreds or even thousands of years. As you settle deeper into your bed, imagine that deep blue light washing over you, cool, calm, and incredibly still. The reason for this sapphire glow lies in the way the dense ice interacts with the very nature of light itself. To understand why the glacier chooses blue, we have to look at how the molecules of water, now packed so closely together, handle the energy of the sun as it travels through the frozen depths. Imagine a beam of sunlight touching the surface of a glacier. That light is a bundle of every color in the rainbow, all traveling together in a white-hot rush of energy. In a fresh snowbank, those colors hit the countless tiny surfaces of the airy flakes and bounce right back almost instantly, reaching your eyes as a brilliant, blinding white. But in the heart of a glacier, where the air has been squeezed out and the ice has become a single, solid mass, the light begins a different, much slower journey. Water molecules have a natural preference for certain types of light energy. As the sunlight penetrates the dense, clear ice, the molecules begin to interact with the light waves. They have a specific resonance that allows them to absorb the longer wavelengths of the spectrum, the warm reds, the soft oranges, and the golden yellows. These colors are gently pulled into the ice, their energy vibrating through the crystals and transforming into the faintest, most microscopic trace of heat. But the shorter wavelengths, the cool, vibrant blues and deep violets, are not absorbed so easily. They are allowed to pass through, bouncing off the large interlocking ice crystals and scattering back toward the surface and into your eyes. The deeper the light travels into the ice before it returns to you, the more pure and intense the blue becomes. It is a subtractive process, a slow filtering of the world's warmth until only the coolest hue remains. Near the surface, the ice might appear as a pale, watery aquamarine, like a shallow tropical sea, but as you look deeper into a crevasse or stand beneath the arched, translucent ceiling of an ice cave, the color shifts. It deepens into a heavy sapphire, then a dark, resonant indigo that seems to vibrate with its own internal energy. It is as if the ice has filtered out the noise and the heat of the sun, leaving behind only the most tranquil, restful color in existence. This is what we might think of as frozen light. When you gaze at that blue glow, you are seeing light that has been refined by the weight of centuries and the density of millions of pressurized snowflakes. It is a visual representation of time and pressure. If the ice were only a few inches thick, it would look as clear and colorless as a glass of water. But when you stack hundreds of feet of ice together, the cumulative effect of those water molecules absorbing the red light creates a cathedral of blue. It is a quiet, heavy color that invites you to be still, to breathe slowly, and to imagine the immense, silent, power that has crafted such a masterpiece. Yet, for all its appearance of absolute stillness and crystalline perfection, the glacier is not a static object. It is not a frozen monument that simply sits upon the mountain unchanging and idle. Within this massive blue-tinted body, a subtle and powerful transformation is taking place. The very weight that squeezes the air out and creates that beautiful blue light is also the force that begins to wake the ice up. Under the relentless, passionate pull of gravity, this mountain of frozen water is preparing to do something that seems impossible for something so solid and so vast. It is beginning to move. It is no longer just a collection of ice. It is becoming a living, flowing river of lightning and frost. In the quiet world of the high mountains or the frozen poles, we often think of ice as something static, something that stays exactly where it was formed, frozen in time. But to the Earth and to the scientists who study these frozen giants, a glacier is defined by one essential, surprising characteristic. It moves. If a body of ice does not move under the pressure of its own weight, it is simply a snowfield or a lingering patch of winter. But once it reaches a certain massive scale, it begins a slow, inevitable journey across the face of the planet. It becomes a living thing, a river made of crystal and time. This transition from a still object to a flowing landscape doesn't happen by chance. It is a matter of physics and the quiet, relentless accumulation of weight. As more and more snow falls and more layers of fern are pressed into that dense, blue glacial ice we've imagined, the pile grows taller and heavier. For a long time, the ice simply sits there, held in place by the friction of the rough rock beneath it. The stones and ridges of the mountain act like tiny anchors, gripping the bottom of the ice and keeping it from sliding away. The ice is stubborn, and the mountain is firm. But there is a specific point, a threshold of weight and depth, where the balance of power shifts. Glaciologists call this the critical thickness. In most environments, this occurs when the ice reaches a depth of about 100 to 150 feet. It is a staggering amount of ice to imagine stacked high toward the clouds. At this height, the sheer crushing weight of the ice above becomes so great that the force of gravity finally begins to overcome the friction of the ground. The downward pull becomes stronger than the grip of the stone. Imagine standing beside a wall of ice as tall as a 10-story building. The pressure at the very bottom of that wall is immense. It is a constant, heavy push, a silent command from the Earth's core, telling the ice that it can no longer stay still. At this critical thickness, the ice begins to undergo a fundamental change. It begins to behave less like a solid, brittle rock and more like a very thick, very cold fluid. It is as if the mountain of ice has finally decided to wake up from its long slumber, yielding at last to the persistent, patient pull of the world below. This movement is not a sudden slide or a quick tumble. It is perhaps the most patient journey on our planet. Even as it begins to flow, the glacier remains a giant of silence. It moves with a dignity that ignores the frantic pace of the world outside its frozen borders. It is a movement measured in inches per day, a slow-motion migration that will eventually reshape everything in its path. As we watch this blue giant begin its descent, we start to see that this movement happens in two distinct and fascinating ways. The ice doesn't just slide as one solid, uniform block. It changes from the inside out and moves along its hidden base in a complex dance of pressure and temperature. To understand how such a massive, brittle substance can flow like a river without shattering, we have to look deeper into the very heart of the ice crystals themselves, exploring the secret ways they shift and slide against one another. Inside the deep blue heart of the glacier, something extraordinary is happening. Even though the ice feels as hard as stone to the touch, the immense pressure of those hundreds of feet of snow above it begins to change the very nature of the ice crystals themselves. This phenomenon is known as internal deformation, or sometimes, more poetically, plastic flow. It is the process by which a solid material, under the right conditions, begins to behave like a fluid, yielding to the weight of the world without ever shattering. Think of the ice crystals we discussed earlier, those beautiful six-sided structures that began as a single snowflake in the clouds. Within the glacier, these crystals are no longer delicate and airy. They have been squeezed and pressed until they are thick and dense. But even under this pressure, they possess a hidden flexibility. When the weight becomes too much to resist, the crystals don't break. Instead, they begin to shift. To visualize this, imagine a deck of playing cards resting on a table. If you place your hand on the top of the deck and push forward gently, the cards don't snap. Instead, each individual card slides just a tiny fraction of an inch past the one beneath it. In the same way, the layers of atoms within the ice crystals begin to glide over one another. This happens throughout the entire mass of the glacier, from the surface down to the depths, though it is most intense where the pressure is greatest. It is a movement that defies our everyday understanding of what is solid. We think of ice as something that cracks under a hammer or melts in the sun, but here, in the cold silence of the mountain, it becomes something else entirely. It becomes plastic. It stretches and bends. It flows with the consistency of very cold honey, or perhaps a thick, viscous syrup. If you were to watch a glacier over centuries, you would see it ooze around corners and over ridges, following the contours of the land like a slow-motion waterfall. This internal deformation is a testament to the power of persistence. There is no hurry in the glacier's world. The ice might only move a few inches in a day, a distance so small it is almost impossible for the human eye to detect in the moment. Yet, over time, this microscopic sliding adds up to a monumental journey. The entire mountain of ice is essentially reorganizing itself from the inside out, atom by atom, crystal by crystal. As the ice flows, it carries with it the history of the snow that formed it, moving that history slowly toward the valleys below. It is a graceful, heavy dance, a slow-motion migration of millions of tons of frozen water. But as fascinating as this internal shifting is, it is only one part of the story of how a glacier travels. While the ice is busy deforming and flowing within its own body, something equally remarkable is happening at the very bottom, where the ice meets the earth. Down there, in the dark, hidden interface between the glacier and the bedrock. A second type of movement is preparing to help the giant slide even further. Down in the deep shadows, where the ice meets the ancient stone of the mountain, a quiet transformation is taking place. The weight of the ice above, thousands of feet of it, is so immense that it creates a tremendous amount of pressure. This pressure does something curious. It lowers the temperature at which ice melts, and when the surrounding environment is well below freezing, the very bottom of the glacier begins to weep. Tiny droplets of water emerge, forming a thin, shimmering film between the ice and the bedrock. This film is no thicker than a few sheets of paper, yet it changes everything. It acts as a lubricant, a liquid cushion that allows the entire massive body of the glacier to glide across the earth. This process is known as basal sliding. While internal deformation allows the ice to flow like honey from within, basal sliding allows the glacier to move as one solid unit over the landscape. It is as if the mountain has been coated in a layer of silk, allowing the heavy, frozen giant to slip forward with a grace that belies its size. Sometimes this water comes from the surface, trickling down through deep shafts in the ice, and other times it is generated by the warmth of the earth itself. But its effect is always the same. It eases the way. Take a slow, deep breath now and visualize this motion. Imagine the vast, white expanse of the glacier, miles long and incredibly heavy. Below it, hidden from the sun, is that thin, secret layer of water. The ice is no longer dragging or scraping against the jagged stone. It is floating, just barely, on a cushion of its own making. There is a profound peace in this image, a heavy, unstoppable force moving with the ease of a cloud, sliding over the obstacles of the world without effort. Feel the weight of your own limbs relaxing into your bed, much like the ice settles into the valleys, supported and carried by a gentle, unseen fluid. However, this movement at the base does not happen in isolation. Because the glacier is not a uniform block of wood or stone, but a complex, changing body of ice, the different ways it moves begin to conflict. The bottom of the glacier, lubricated by meltwater, might surge forward, while the ice higher up moves at its own, slower pace. This creates a hidden drama on the glacier surface. As the base slides and the middle flows, the topmost layers are pulled and stretched. Unlike the deep ice, which is flexible under pressure, the ice at the very top is cold, hard, and unforgiving. It cannot stretch to keep up with the slide below. As the glacier continues its journey down the mountain, this tension builds until the surface can no longer hold itself together. The top 150 feet of a glacier is known to glaciologists as the brittle zone. This is the skin of the glacier, the part that remains stiff and unyielding even as the massive body beneath it begins to flow. Think of it like a layer of cold, hard wax resting on top of a pool of warm, moving honey. While the deep ice is under so much pressure that it becomes plastic, capable of bending and warping without breaking, the surface ice is under much less pressure. It is exposed to the biting cold of the mountain air, which keeps it rigid and firm. As the glacier slides forward on its thin cushion of meltwater, or as it pours itself over a hidden ridge in the bedrock, the surface ice is forced to keep up. But because it cannot flow, it must break. The tension pulls at the ice until it reaches a breaking point, and with a low, resonant sound, a crevasse is born. These are deep, narrow chasms that can reach down over 100 feet, stopping exactly where the ice becomes soft enough to flow rather than snap. In the brittle zone, the ice is a solid, but below that threshold, the pressure is so great that the ice behaves like a slow-moving liquid. If you were to stand in the profound silence of a high-altitude valley, surrounded by these frozen giants, you might hear the glacier speaking. It isn't a sharp or jarring noise, but rather a series of deep, echoing groans and muffled thuds that seem to come from the very heart of the mountain. It is the sound of the ice adjusting itself, settling into the contours of the valley, and breathing as it moves. It is a slow, rhythmic language, the sound of a landscape in motion over centuries rather than seconds. These sounds are most common when the sun begins to set and the temperature drops, or when the glacier moves over a particularly steep section of the mountain. Take a moment to imagine that sound now, a low, vibrating hum that feels like a gentle weight against your chest. It is a reminder of the sheer scale of the world and how even the hardest ice must eventually give way to the slow, steady pull of gravity. Just as the ice finds relief by opening into a crevasse, allow yourself to release any tension you might be holding in your shoulders or your jaw. Let the weight of your body sink deeper into the mattress, matching the heavy, settled presence of the glacier in its valley. There is no rush in this movement. It is a process that takes years to unfold. While the surface of the glacier is busy cracking and shifting to accommodate the movement below, the underside of the ice is engaged in a much more intimate struggle with the earth. The relationship between the glacier and the mountain is not just one of sliding, it is a physical conversation of immense power. As the ice moves, it doesn't just pass over the rock. It begins to change it, reaching down with a frozen grip to claim parts of the mountain as its own. The weight of the ice above provides the force, but it is the temperature and the slow, steady movement that allow the glacier to begin its work of reshaping the very foundation of the world. As the glacier moves, a process known as plucking begins to unfold in the dark, pressurized space where the ice meets the mountain's spine. It starts, quite simply, with a small amount of meltwater. This water, warmed slightly by the immense pressure of the ice above or the subtle internal heat of the earth, trickles into the tiny cracks and joints of the bedrock beneath. In the profound stillness of the deep ice, this water finds a temporary home in the mountain's crevices. But as the glacier shifts and the temperatures fluctuate, that water freezes once again. It expands, pushing against the walls of the rock, widening the cracks just a fraction of an inch at a time. This is the quiet, patient work of the ice. Eventually, a piece of the rock is no longer part of the mountain's solid foundation. It is held fast within the frozen embrace of the glacier itself. As the massive body of ice continues its slow, inevitable journey downslope, it simply lifts the rock away, plucking it from the ground as easily as one might pick up a fallen leaf from a garden path. Once these stones are claimed by the ice, they become silent travelers. Some are small, no bigger than a piece of fruit, while others are as massive as a house, weighing many tons. The glacier carries them within its frozen belly, cradling them for miles and miles across the landscape. These travelers are known as glacial erratics, Stones that seem to have appeared out of nowhere, resting in fields or perched on top of hills where the surrounding geology doesn't quite match. To see a giant granite boulder sitting alone in a meadow of soft soil is to see a souvenir of a journey that took centuries to complete. These erratics are the heavy, grounded witnesses to the ice's long memory, serving as a physical record of where the glacier has been and what it has gathered along the way. There is a profound sense of peace in this kind of power. It isn't the sudden, jarring force of a storm or the chaotic rush of a flood. Instead, it is the strength of absolute persistence. It is the weight of time itself, pressing down with such consistency that even the hardest granite eventually yields. Imagine the glacier as a slow, rhythmic breath of the planet, moving with a purpose that doesn't require haste. This steady pressure is what allows a soft substance like ice to reshape the very bones of the earth. It is a reminder that the most significant changes often occur through the quiet, steady accumulation of small movements, 1 inch at a time, until the landscape is transformed. But the glacier does more than just lift and carry the mountain's pieces. As it holds these plucked stones firmly in its base, it turns them into tools. The rocks embedded in the bottom of the ice act like the grit on a piece of cosmic sandpaper, but on a scale that is difficult to fathom. As the glacier slides, it uses these captured stones to scour and sand the landscape beneath it. This is the beginning of a different kind of transformation, a grinding action that smooths the rough edges of the world. The mountain is no longer just being moved, it is being polished into something new and elegant. As the ice moves forward, the heavy stones at its base begin to wear down, turning the hard rock into something much finer, a soft residue that will eventually change the color of the world. As the glacier continues its slow, heavy slide, the rocks caught in its underbelly are pressed against the bedrock with the weight of an entire mountain range. Under this immense, steady pressure, the stones do not simply break, they are pulverized. They are ground down into a substance so fine it feels like silk or talcum powder between the fingers. This is what scientists call glacial flour or rock flour. It is the result of thousands of years of friction, a physical testament to the incredible abrasive power of ice when it is paired with stone. Imagine the silence of this process. Deep beneath the frozen surface, where no light reaches, the earth is being sanded. The glacier acts as a massive, slow-moving lathe, smoothing out the jagged edges of the world. This rock flour is made of minerals like quartz and feldspar, ground so small that they lose their individual identity and become a collective, whisper-thin dust. It is the very essence of the mountain, reduced to its most basic form by the patient, unyielding force of the ice. This fine silt doesn't stay trapped beneath the ice forever. When the warmth of the sun or the friction of the movement creates meltwater, this water carries the glacial flour away. It flows in tiny, milky streams that eventually find their way into alpine lakes and rivers. If you were to stand on the shore of a lake fed by a glacier, you would notice something extraordinary. The water isn't the clear, transparent blue of a backyard pond. Instead, it is a vibrant, opaque turquoise, a color so bright and saturated it almost looks as though it were painted onto the landscape. The reason for this luminous beauty is a gentle dance of light and physics. Because the particles of glacial flour are so incredibly small and light, they do not sink to the bottom of the lake like ordinary sand or pebbles. Instead, they remain suspended in the water for a long, long time, floating like a fine mist in the air. When sunlight hits the surface of the lake, these tiny bits of rock scatter the shorter wavelengths of light, the blues and the greens, back toward your eyes, while the water itself absorbs the longer, redder wavelengths. This creates that iconic, milky, jewel-toned appearance. The lake becomes a mirror of the grinding mountain high above, a liquid memory of the ice's hard work. Take a slow, deep breath and visualize that turquoise water perfectly still and calm, reflecting the white peaks that created it. There is a profound sense of balance here. The harsh, grinding power of the glacier, capable of crushing solid granite, ultimately produces something of such delicate and ethereal beauty. The abrasive strength of the ice and stone is not just a force of destruction, it is a creative act. This constant sanding and polishing does more than just color the water. It fundamentally changes the shape of the Earth's surface. Unlike a river, which might cut a narrow, jagged path through a canyon, the glacier's abrasive power is broad and relentless. It doesn't just cut, it sands. It doesn't just move through the landscape, it polishes the very bones of the world. As the glacier moves forward, year after year, it prepares the mountain for a transformation that will define the skyline for eons to come. The rough, broken terrain is slowly being smoothed into the grand, sweeping curves that characterize the most majestic landscapes on our planet. As this sanding and polishing continues over centuries, the very geometry of the Earth begins to change. If you were to look at a map of the world's mountain ranges, you could tell exactly where the ancient ice once lived, simply by looking at the shape of the valleys. When a river flows through a mountain range, it acts like a delicate scalpel. It cuts a deep, narrow path through the center, eroding only the very bottom where the water touches the rock. This creates what geologists call a V-shaped valley, steep, jagged, and sharply angled at the base. But a glacier is not a scalpel. It is a massive, heavy plane, a woodworking tool of continental proportions. Because a glacier is a solid mass that fills the entire valley from wall to wall, it exerts its incredible pressure in every direction at once. It doesn't just erode the floor, it pushes against the sides, grinding away the rough edges and protruding ridges of the mountain. Imagine the ice as a giant, slow-moving plug, fitting perfectly into the contours of the land and gradually widening them over thousands of years. This relentless outward pressure transforms the landscape into a U-shaped valley. These valleys are characterized by wide, flat floors and nearly vertical walls that curve upward with a grace that seems almost intentional. Take a moment to visualize one of these great valleys. The floor is a lush, green meadow, perhaps with a small, winding stream now occupying the space where a mountain of ice once stood. The walls on either side are smooth, sheer cliffs of granite, rising thousands of feet into the air. These are the majestic fjords and glacial valleys we see today, places like Yosemite in California, or the deep water-filled inlets of Norway. They are, in a very real sense, the ghosts of ancient ice. The ice is gone, returned to the sea or the atmosphere, but its signature remains etched into the very bones of the planet. When you stand in a U-shaped valley, you are standing in the hollow space where 1 billion tons of ice once rested, slowly carving its masterpiece into the stone. There is a profound stillness in these places, a sense of deep time that invites us to slow our own internal rhythms. The mountain did not fight the ice. It simply allowed itself to be shaped by it. It accepted the slow, heavy weight and the patient grinding until something new and beautiful emerged. This transformation did not happen in a day or a year or even a century. It happened at what we have come to call a glacial pace. In our modern world, we often think of speed as a virtue, but the glacier reminds us of the power of the slow and the steady. To move at a glacial pace is to move with the weight of history and the certainty of purpose. It is a speed so deliberate that it is almost indistinguishable from rest. As you settle deeper into your blankets, let the idea of this patient movement wash over you. There is no need to rush, no need to reach the destination quickly. Like the ice, we can find our strength in the slow, unhurried passage of time, trusting that even the smallest movements, when sustained, can move mountains. This pace is the heartbeat of the frozen world, a rhythm that guides the glacier as it journeys across the land. This movement we call the glacial pace is something truly remarkable when you consider the sheer scale of the ice. To our human eyes, a glacier looks like a permanent fixture of the landscape, as unmoving as the mountain peaks that surround it. But if we could speed up time, we would see that these massive bodies are constantly in flux. On average, most glaciers move only a few inches to a few feet per day. Imagine a giant river of ice, miles long and hundreds of feet deep, advancing no further in 24 hours than the length of a small step. In the time it takes for you to rest here, drifting toward sleep, the glacier may have only moved a fraction of an inch. It is a movement so subtle that if you were to stand before the ice for an entire afternoon, you would see no change at all. You would hear only the occasional groan of the internal crystals shifting, a reminder that the ice is alive with gravity's pull. Occasionally, however, the ice finds a different rhythm. Scientists speak of surging glaciers, rare and fascinating events where a glacier suddenly accelerates, sometimes moving as much as 100 feet in a single day. In the world of glaciology, this is considered a sprint, a frantic, high-speed dash compared to the usual crawl, yet even during a surge, the glacier is still moving slower than a person taking a leisurely walk through a garden. Even at its most hurried, the ice remains a master of patience. It does not rush with the chaotic energy of a mountain stream. It maintains its dignity, flowing with a heavy, deliberate grace. It reminds us that speed is relative, and that even a sprint can be a peaceful, steady process when viewed on the scale of the earth. Take a slow, deep breath now, and let the air move through you with that same steady, unhurried rhythm. There is no rush in the world of the ice, and there is no rush here in this moment. You have nowhere you need to be and no tasks left to complete. Like the glacier, you can simply exist in this state of slow transition, letting go of the need to arrive anywhere quickly. Feel the weight of your limbs as they settle into the mattress, finding comfort in the stillness. The world outside may move with a frantic energy, but here we are embracing the quiet power of the slow and the steady. We are moving at the pace of the seasons, at the pace of the falling snow and the creeping ice. There is a profound safety in this slowness, a sense that everything is happening exactly as it should in its own time. As the glacier moves across the landscape, it does more than just carve valleys and grind stones. It acts as a silent guardian of the world's history. Because a glacier is built from layers of snow that have accumulated over hundreds or even thousands of years, it becomes a literal frozen record of time. Every inch of that deep blue ice was once a flurry of snowflakes falling through an ancient. As those flakes were pressed together, they didn't just turn into ice. They captured the very essence of the world as it was in that moment. The glacier is not just a moving body of water, it is a living time capsule, a library made of cold and light, carrying the secrets of the past deep within its frozen heart. It moves through space, yes, but it also carries the atmosphere of centuries long gone, preserving the story of our planet in a way nothing else can. Within these deep blue layers of ice, something remarkable is happening. As the snow of centuries past was compressed by the weight of the layers above it, the air that once circulated between the flakes didn't simply disappear. Instead, it became trapped. Tiny, microscopic bubbles of air were sealed away, encased in a crystal tomb of ice. These bubbles are not just empty spaces, they are tiny, pressurized capsules of the atmosphere as it existed at the very moment those snowflakes were first buried. They are samples of the ancient sky, preserved with perfect integrity for thousands of years. To reach these secrets, scientists journey to the most remote corners of the earth, where the ice is thickest and oldest. They use long, hollow drills to pull out what are known as ice cores. Imagine a gleaming cylinder of ice, several inches wide and many feet long, brought up from the dark depths of the glacier. When you look at an ice core, you are looking at a vertical timeline of the Earth's history. Each layer is like the ring of a tree representing a single year of snowfall. By counting these layers and analyzing the chemistry of the ice and the air trapped within it, we can read the story of our planet's climate as if it were written in a book. In these frozen cylinders, we find traces of everything the Earth has experienced. There are layers of fine dust from ancient droughts and microscopic traces of ash from volcanic eruptions that happened long before recorded history. But perhaps most incredible of all are the bubbles themselves. When a scientist melts a small piece of this ancient ice in a vacuum, those tiny bubbles finally burst. It is a soft, microscopic fizzing, the literal breath of the world from 10,000, 50,000, or even 800,000 years ago, escaping into the present for the first time. To hold a piece of this ice is to hold a physical piece of the past, a cold and heavy witness to the passage of eons. This process of preservation is a quiet, ongoing miracle. While the world above changes, while forests grow and fall and civilizations rise and fade, the glacier keeps its silent vigil, holding on to the air of the past with a steady, frozen grip. It reminds us that nothing is truly lost. It is simply transformed or tucked away, waiting for a moment to be rediscovered. As you lie there, let your mind rest on the idea of this deep, peaceful storage. Just as the glacier holds the history of the atmosphere, your own mind can set aside the events of the day, tucking them away into the quiet layers of memory where they no longer need your active attention. You can let the now be simple and still, knowing that the important things are safely kept. But even a time capsule as vast as a glacier must eventually reach its limit. The ice is never truly stationary. It is a river, and every river has an end. As we move away from the high, cold plateaus where the ice is born and the deep centers where it stores its secrets, we follow the flow downward. The glacier continues its slow, heavy march, following the contours of the mountain, moving toward the lower elevations where the air begins to warm. We are approaching the very edge of the ice, the place where the frozen journey of the snowflake finally meets the boundary of the changing seasons. As we follow this slow-moving river of ice down the mountain, the air begins to change. It is still crisp and cool, but it loses that biting, thin quality of the high peaks. We are approaching the very end of the glacier's long journey, a place known as the terminus, or more evocatively, the toe. This is the leading edge of the ice, the point where the glacier's frozen life meets the warmer world below. Imagine standing before this massive wall. It might be a towering cliff of cracked, blue ice, or a gentle, sloping mound covered in gray silt and stone. This is a place of profound transition. Here, the ice that has traveled for centuries finally yields to the sun. You can hear it if you listen closely, a soft, rhythmic dripping, the sound of ancient snow returning to its liquid form. It is a patient, steady sound, like a clock ticking in a very quiet room. To understand why the glacier ends exactly where it does, we can think of it as a great frozen balance sheet. Scientists call this the glacial budget. On one side, we have accumulation, the fresh snow falling in the high, cold basins, adding weight and mass to the glacier's start. On the other side, we have ablation. This is the sum of all the ways a glacier loses its ice, through melting, through evaporation directly into the air, or through calving, where great chunks break off into a lake or the sea. Every moment of the glacier's existence is a quiet negotiation between these two forces. If the winter snows are heavy and the summers are cool, the accumulation exceeds the ablation. The glacier grows heavy and its toe inches forward, reclaiming the land. This is a glacial advance, but if the sun stays longer and the snows are thin, the ablation wins. The ice at the terminus melts away faster than the flow from above can replace it. When this happens, the glacier is said to retreat. It is a common misunderstanding to think the ice itself moves backward during a retreat. In truth, the ice is always flowing downward, pulled by gravity, never stopping its march toward the valley. A retreating glacier is simply a river that is vanishing at its end faster than it can be replenished at its source. Even as the front edge pulls back, the ice behind it continues to slide forward, a relentless, slow-motion conveyor belt. When the snowfall at the top perfectly matches the melting at the bottom, the glacier reaches a state of equilibrium. The toe stands still, appearing motionless for years or even decades. Yet, inside, the ice is still moving, still flowing through the mountain's curves, constantly being born at the peaks and dying at the base. It is a state of dynamic rest, a massive, frozen entity that is perfectly still and yet in constant fluid motion. As you breathe in the cool, damp air of this transition zone, visualize the ice at the terminus. As it melts, it can no longer hold on to the secrets it has carried for miles. All the rocks, the boulders, and the fine, silty glacial flour that were frozen into its belly are finally released. They tumble out of the ice, clattering softly onto the ground. The glacier, which began as a single pure snowflake in the high atmosphere, is now heavy with the weight of the earth. It sheds this burden here at its end, leaving behind a chaotic and beautiful trail of stone. This debris is the physical memory of the glacier's path, a record of everywhere it has been and everything it has touched. The ice is letting go, turning back into the water it was always meant to be, leaving the solid world behind to mark the place where it once rested. These remnants, scattered at the foot of the melting ice, tell a story of a journey that is nearly complete, preparing the landscape for what comes after the ice is gone. As the ice retreats, it leaves behind more than just scattered stones. It leaves behind great ridges and mounds of earth known to geologists as moraines. Think of a moraine as the footprint of a giant. When the glacier was at its largest and most powerful, it pushed a wall of soil, gravel, and boulders ahead of it, much like a slow-moving plow. When the climate warmed and the ice began to pull back, it could not take that wall with it. The debris stayed right where the ice had dropped it, forming a long, curving hill that marks the exact boundary of the glacier's furthest reach. This is called a terminal moraine. It is the high water mark of a frozen sea, a silent witness to a time when the world was much colder and the ice was much deeper. There are also lateral moraines, which run along the sides of the glacier's path, marking how wide the river of ice once was. When you look at a mountain valley today and see these long, straight ridges of stone hugging the slopes, you're looking at the banks of an ancient frozen river that has since evaporated into memory. Walking along the crest of a moraine today, you might see wildflowers growing in the rocky soil, or a thick forest that has taken root over many centuries. But beneath the green leaves and the soft moss, the shape of the land still belongs to the ice. The landscape remembers where the glacier once slept. These ridges are the scars and the stories of the Earth's past. They show us that nothing is truly lost. The energy and the weight of the glacier are simply transformed into the hills and valleys we walk upon today. Even when the ice is long gone, its presence is felt in the curve of a slope or the placement of a giant boulder sitting solitary in a grassy field, miles from the nearest mountain. These erratics, as they are called, are travelers that have finally come to rest, held in the palm of the land. They are heavy, silent reminders of a power that moved with absolute patience. As we watch the terminus of the glacier, we see that the story is shifting from the solid and the heavy back to the fluid and the light. The ice that has spent centuries, perhaps even millennia, as a solid crystal is finally yielding. Under the gentle warmth of the sun, the blue ice turns into a steady drip, then a trickle, and finally a rushing stream. This is the beginning of the return, the snowflake that began its journey in the high, cold clouds, that fell to the earth and was pressed into the heart of a glacier, is now becoming liquid once more. It is shedding its frozen form and re-entering the great eternal cycle of water. It flows away from the moraines, away from the shadows of the mountains, seeking the lowest point it can find. The journey of the ice is ending, but the journey of the water is just beginning, carrying the minerals of the mountains and the coolness of the ancient sky down toward the world below. It is a release, a letting go of the tension of the solid world as the water prepares to find its way back to the vastness of the sea. As the ice yields to the sun, the meltwater gathers in small turquoise pools at the foot of the glacier. These pools overflow, sending ribbons of cold, clear water down the rocky slopes in a gentle, melodic rush. This is more than just a seasonal thaw. It is the source of life for vast regions of our planet. Glacial meltwater feeds some of the world's largest and most iconic rivers, the Ganges, the Indus, the Yangtze, and the Brahmaputra. These rivers, born from the high frozen peaks, provide water for drinking, for agriculture, and for the very survival of hundreds of millions of people. The ice, which seemed so remote and desolate in its high mountain home, is actually the steady pulse of the valleys below. It acts as a slow-release reservoir, holding on to the winter's bounty and giving it back to the earth exactly when it is needed most, during the heat of the summer months. Imagine a single drop of this water that was once a six-sided snowflake falling through a quiet, prehistoric sky. That flake may have landed 10,000 years ago, during a time when the world looked very different than it does today. It has spent 10 millennia in the cold and the dark, pressed under the weight of a mile of ice, moving inch by inch across the bedrock in a journey of incredible patience. And now, at long last, it is finally free. It flows through the mountain streams, tumbling over smooth stones and rushing through deep, shaded canyons. It joins with countless other drops, gaining momentum as it leaves the mountains behind and enters the wide, flat plains. The water carries with it the microscopic dust of the mountains, the glacial flour that turns the river a soft, milky green. It is a traveler returning from a very long journey, carrying the chemical memory of the ancient atmosphere back into the modern world. Take a slow, deep breath and feel the rhythm of that water as it moves. It is a steady, unstoppable flow, much like the air moving in and out of your lungs. There is no hurry now. The steep descents are over, and the river broadens and slows as it nears the coast. The air grows warmer and saltier. The fresh water of the mountains finally meets the salt water of the ocean. The snowflake has completed its cycle. It began as a vapor in the sky, became a crystal in the cold, lived as a solid in the heart of the glacier, and has now returned to the vast, restless cradle of the sea. It is a perfect circle, a journey from the heavens to the earth and back to the deep blue of the world's oceans. As the river merges with the tide, the individual identity of that ancient snowflake is lost, but its essence remains part of the whole. It is home. The journey from sky to ice to ocean is finished. and the water is ready to rest before it begins again, to be lifted by the sun once more, to become a cloud and perhaps, one day, to fall as snow upon another mountain. Everything is connected in this quiet, revolving system. There is a profound peace in knowing that nothing is ever truly gone. It is simply moving through another phase of its long, beautiful existence. We are nearing the end of our own journey now, having followed the path of the ice from its smallest beginning to its greatest end. In these final moments, we can look back and see the harmony of the world, where even the smallest flake of snow plays a part in the grand, slow movements of the earth. We have traveled a long way together following a path that began with a single, invisible molecule of water vapor high in the freezing reaches of the atmosphere. We watched as that molecule found a microscopic speck of dust, a tiny piece of the Earth's story, and began to build a crystal of perfect, six-sided symmetry. We saw how the cold and the wind dictated the growth of those delicate branches, creating a shape that had never existed before and would never be exactly replicated again. From that one quiet descent through the clouds, we watched the landscape transform. We saw the individual flakes lose their air and their lightness, pressing together under the weight of time and gravity until they became the dense, ancient blue of glacial ice. We felt the slow, resistible crawl of the glacier as it carved through solid rock, grinding mountains into flour and holding the atmosphere of the past in tiny frozen bubbles, and finally we followed the meltwater as it returned to the sea, completing a cycle that has repeated for millions of years. There is a profound beauty in these slow, natural processes. They require no effort from us. They do not ask for our intervention or our observation. In the highest peaks and the most remote polar reaches, the snow continues to fall, the ice continues to flow, and the earth continues to reshape itself in a rhythm that is far older than human history. There is a deep comfort in this endurance. The world moves at its own pace, unhurried and constant, governed by the simple, elegant laws of physics and chemistry. As you lie here now, you could lean into that same sense of constancy. You are a part of this world, and you are allowed to move at your own slow pace. You are allowed to let go of the day's momentum and sink into the quiet, heavy stillness of the ice. Imagine the snow of your mind, the many thoughts, worries, and observations of the day beginning to settle. Just as the air in a snowbank eventually escapes to leave behind a solid, peaceful foundation, let the restlessness leave your body. Let your thoughts drift down slowly, layering one upon the other until they become a soft, silent blanket. There is no need to sort them or hold on to them. They are simply settling, becoming part of the quiet landscape of your rest. Feel the weight of your limbs as heavy and relaxed as a glacier resting in its valley. Your breathing is the only movement now, a slow and steady tide that mirrors the rising and falling of the seasons. The journey is complete. The mountains are still, the ice is silent, and the water has found its way home to the sea. Everything is exactly where it needs to be. As the world outside continues its slow, ancient revolutions, you can drift off into a deep and restorative sleep. The darkness is warm, the silence is full of peace, and the morning is a long way off. Let the blue light of the deep ice fill your mind with a sense of calm, and let the rhythm of the falling snow carry you away Sleep now, deeply and peacefully, as the quiet science of the world carries on without you. Sleep, sleep, sleep,